This video is on nuclear magnetic resonance. Most atoms have magnetic states in their nuclei. When two or more states are available within that nucleus, we can measure difference between the two states. In the presence of a strong magnetic field, we can obtain signals from these atoms. The surrounding electron density around these nuclei can have an effect on the signal, and therefore, when we graph those signals on a spectrum, they will appear in different positions depending on the environment the nuclei are in. The location where the signal appears on the spectrum is referred to as the chemical shift. The most common atoms to be analyzed using nuclear magnetic resonance are the proton and carbon-13 isotope of carbon. Incidentally, this makes NMR extremely useful in organic chemistry as all molecules will have a carbon and most will have hydrogens.